You ready?
No, give me another 5 minutes.
Okay. I just ran here from the airport, so I know what you mean, but these people are just off of lunch, so they're starting to feel drowsy, so I figure it's up to us to wake them up.
All right, let's make sure we say at least one really stupid thing.
Well, I'm going to quote you, so we'll start with that. Okay, great. Okay? This is going to be a quote fest because he said so many cool and fun things. So the first thing is, when you and I talked before this, you said AI is actually key to human survival. And you have so many people that are saying AI is going to cause an existential crisis, and you really positioned it as actually AI is our existential shield.
Yes.
So I'd love to hear more of your thinking on that, and because it's contrary to some of our tech community's conventional wisdom.
It is, and clearly there are many ways this could go, but I grew up in the age when Margaret Thatcher and Ronald Reagan were in power, and I was living in England and really worried that there was going to be a nuclear war every day. And at that point, I kept thinking, why are we letting humans run the world? Like, why can't machines do a good job instead? I've fallen back from that extreme position, but it really is the case that there are some tasks which I think that humans and machines working together can keep the world safer than when they're not. So after a large flood, you want to be able to use a combination of people and machines to search for folks who are in danger in the water or in other kinds of trouble. When it comes to things like dealing with the effects of climate change, there are places now, the Robotics Institute at Carnegie Mellon is one of them, that are building giant robots able to rapidly pick up large rocks and start to build emergency levees as a storm comes in. These are the kinds of things which, when you look at the problems in the world, we do have technology on our side to at least help us with some of those problems.
You're speaking my language. I firmly believe that we make a big mistake in AI when our judgment is the machine is better than the human. Because I think our judge should be human and machine together are better than anything else. And you see that with chess, you see it with weather prediction that you brought up. It's just repeated over and over again. When we do pair the two, we're very different things.
Yes, yes. And just for the record, I'm not sure if this room would agree, artificial intelligence is still hugely, hugely far away from anything like human cognition or human creativity. Even really simply defined formal questions about what it means to think outside the box. We, in the AI world, are just infants at dealing with that. But the good news is there are some things, especially around perception or detecting patterns or choosing among 10 to the 53 different possibilities, which we can do extremely well.
And you've referred to those things so far as artisanal works, which I love that you put that in there. So you think of the craftsman that had, the master craftsman that had to be really trained and spend years doing this. But one of the things you want to do, and when you rejoined Google, you said, I really want mass accessibility.
Yes.
And one of the examples you gave of that was a history major at CMU who took an AI course and then did an AI system for American Sign Language to help people learn how to better sign.
Yes.
And so I think that's such a great example of something that's accessible and someone that has a passion, because I think one of her siblings was deaf.
Yes.
And that's very accessible to a history major. What other examples do you have of that type of accessibility that excite you when you've seen it?
What we're seeing is with tools which make, especially machine learning, easy by automating a bunch of things which us professional data scientists do, that folks can get creative. Another nice example was the British Zoological Society really wanted to be able to do accurate counting of critters in different forests, I think mostly in northern Africa and other parts of the world. And they did have cameras which they could put a little bit of compute on, but they had no real artificial intelligence expertise themselves. And honestly, if we were back in 2010, the way we'd have dealt with that is to say, well, let's find a professor and a couple of PhD students to do their PhD on this research question of how cameras all around the forest can count critters. What these folks were able to do without having to hire PhDs or any of these things is just give the computer, I think, about 5,000 examples of images with critters in them and a few tens of thousands without. And then one of the systems we built to automate these things, it's called AutoML, which is a very unimpressive name for a very impressive product, was able to do the data science work of figuring out which is the right model, which is the right learning rate, whether to use a neural network or a decision tree and all of those kinds of things. And now they have the system up and running, and it didn't require those years of a PhD or more generally this sort of artisanal approach.
I love that. I saw a similar example of someone using AI to detect illegal logging in the rainforest.
Yes.
So similar kind of thing
Yes.
where they weren't ML experts at all and used tools like this to enable some very simple equipment that they had strung together so that they could detect that faster.
Yes.
So,
if you don't mind, I want to
oh, no, please.
mention that, because that kind of thing is really interesting, and it's part of what I'm about to describe, I think, is illustrative of the fact that we're not in a static environment. We're actually in an area where AI is changing every year. So Professor Fei Fang used machine learning to help with a similar problem of poaching in big game parks in Africa. And with a combination of drone surveillance and just sending out human rangers, you can try to prevent those. So the first thing she did was learn a system for predicting where the poachers are likely to go. And then the rangers can deploy themselves in those areas. That's machine learning 101. What then immediately happened, as many of you probably suspect, is the poachers realized that the rangers were being deployed in smart places, and so they went to the second or third most obvious place. And the machine learning system had a little bit of trouble then because it was getting confused because things kept changing. That led us, or this professor, to use game theory, exactly the same kind of AI that's being used in poker and other things like that, to use the machine learning to come up with strategies which will maximally confuse what's going on. So this question of sometimes it's not enough to predict what's the right thing to do using machine learning and then do it. You've actually got to predict what could be done and then take into account things like malicious opponents when you're deploying it.
And I think you're hitting on something really key with these examples too. So I started in AI in 1989, back at Los Alamos, and we had basic neural net. We had data, because we were at Los Alamos and we could get data easily, and we had compute power. But we didn't, and we had computer scientists, mathematicians, but what we didn't have is more accessibility. And that's one of the things I also love that you've said is that is actually what's going to drive the innovation is accessibility. It isn't going to be the technology, which, as you said, it's not much different from what we were working on 30 years ago. But that accessibility that we've just been talking about is really what's driving that. Can you talk some about what that really means? What does it mean when we say accessible?
I think, like many other areas, if you watch the life of a data scientist and ask what makes this person excited to get out of bed in the morning, it is the meaning of whatever problem they're solving. If it is like identifying potential sex trafficking victims, or if it is helping people have a really good experience when they enter a movie theater, those are inspiring things. There's also some excitement about using machine learning methods. But underneath those really compelling things, there's huge amounts of grunge work. The thing that I think many of us are familiar with is all the work you have to do to prepare the data, get it into the right form, join with secondary and tertiary things. That's a pain, and there is some technology which you can use to help that. But there's other stuff as well. One of the biggest problems that this data scientist who wants to be able to launch a useful system has is they've got to worry about whether it's going to be able to run safely for the next 3 years, whether it's going to be reliable, especially if lives might depend on it or there's a large financial impact. So there's all this sort of overhead work that they have to worry about. And so when you picture the life of a happy data scientist and the time when they figure out, wait, I just take the Fourier transform of this one, plug it into the RNN, and I get my result. That's 15 minutes of happiness in her 7-week product of mostly dealing with it. So I can't automate those kinds of mathematical insights that this data scientist had, but I can help remove the rest of all that stuff which is slowing her down.
And understand with AutoML which data set matches with which algorithm and things like that, so that people have an easier time of that and they don't have to become experts in every type of algorithm.
Yes, but I want to be cautious not to oversell that, because it still requires wisdom from this data scientist to decide what to use out of AutoML.
And I completely agree with you there. That's my next question, is about expertise. And one of the things that you said is, it's not that the technology you don't need expertise there. We're always going to need engineering expertise, and that's really important. But where we're really lacking as we think about how we grow AI is in the vision expertise. How do we come up with a vision? And so the way I summarize it, because I'm simple folk, is we're moving from engineering being the problem to the problem statement being the problem.
Yes.
And how do we get good at making those problem statements such that we're not limited by the past and we can still look in the future, but we're grounded in reality?
Yes. It's, by the way, I don't have, and I don't think anyone has the right answer to this yet. So the phenomenon I'm about to describe is something that I'm passionate about, but do not feel confident about. And it is this. Both in my academic life and in my commercial life, I do have many folks from industries or government organizations coming and describing that they want to use AI for something, or there's some problem to solve. And with one or two exceptions, usually after we've been through a successful deployment and I look back at it, the most significant piece of work was the change management from the organization that was going to use this. You can't do massive automation or putting in superhuman abilities in some part of the system without completely disrupting how an organization works. So I think the age of tools providers telling these big companies that have got big business problems, here, take my tools, you figure out how to put them together and you'll solve your problem. That age is behind us. And it will look like, it will start to look like if you're trying to teach someone to play tennis, you say, here, take this racket and these awesome sneakers, and you're basically done. That is not the main thing. The main thing is helping an organization figure out how to deal with the fact that it's going to be using more automation and much more insight in its decisions.
So let's go a click deeper on the org. So 3 years ago, I actually did a talk called It's the Org Stupid.
Very good.
And the reason why I had said that is what I was seeing then, and it's gotten a little better now, but still not great, to your point. What I was seeing then in our customers was what was really hurting them with AI was their org. They didn't have people working together. They weren't a team, as we've learned, although not great in software in general, having a product manager and an engineer and a designer work together, and now a data scientist coming in.
Yes.
It's that team. What is your advice for who is involved? You know, you talked about the data scientist. Who does the data scientist need to get involved in an org for the folks out here that are getting started, that have had those failed projects?
I think, and this is going to sound a little trite, but I really, really want to push it. you shouldn't join a project unless it has got a clear and measurable benefit, and really benefit to the world, something that's inspiring and makes your soul want to get out of bed in the morning. Once you've got a goal and it's important enough that other people will share the same goal, it's so much easier to form a team where you're willing to just throw the ball to each other and keep moving forwards towards that goal. If instead you find yourself in an organization which says, right, we're going to introduce artificial intelligence because our competitors have got artificial intelligence, so we need someone to build a data lake, and we need someone to go and brand our AI tools or something which the danger signal there is it's doing lots of stuff with the words AI, but which is not connected with a specific big business problem. That will be the warning sign. So number one, team motivation thing are these strong goals. This is why you see such amazing performance when, for instance, the government will sponsor big AI competitions. Very, very clear outcomes. Everyone knows why they're doing what they're doing, and they go for it. When I've been involved in some of the projects for managing potential disasters or mitigating existing disasters, it's so much easier management task to get everyone working together. So I know it's kind of avoiding some of the hard bits of this question, but I would just try to walk away from a project which doesn't really know why it's doing AI.
How do you organize your organization at Google? How do you think about that for, you guys are on the forefront. So what could we learn about what you do?
Well, I think it actually comes down to the same sense of urgency. I am quite frightened by how many big potential problems there are in the world, and I want there to be millions of people around the world who are able and equipped to go after and deal with them using as much technology as possible. And so we talk about that this is the purpose of what we're doing, and then we celebrate whenever we see either that we've helped with solving one of those problems, or for, if you like, triple the points when we've introduced a piece of process or a piece of technology which is helping accelerate lots of other people doing it. So again, it comes down to that, what is the thing that really gets us excited? For me, it is this central unsolved question of artificial intelligence, which is how does it become routine and something which millions of people can do? That then drives us. And when we get organizational conflicts, things like two groups are working on a project which seems to be overlapping and they're getting worried about each other, you can use this higher purpose to help sort of de-conflict this, to ask how do we make the best use to go after the higher purpose questions.
So that higher purpose is often limited by the data we have, the bias that's in that data, the ethics that are involved in creating the system. How do you bring all of those together? How do you think about that? How do you think about enabling other people when you're not ever going to know the data because your purpose is to be that tools provider?
Yes. So you gave me like 15 really hard questions, all sort of mashed up in a ball of misery there.
Yeah.
So
I do that on purpose.
Okay.
I was interviewed this morning and he started off with the question of, why does AI hate women?
That's right.
And I was like, yeah, that's about 25 different questions wrapped up there.
Yes.
So I feel your pain.
Yes, but still, it is, this should actually inspire people, I think, to be in the discipline that right now there is this power tool available for the human race, but it has to be used properly and thoughtfully. While I was Dean of Computer Science at Carnegie Mellon, the biggest question I was getting from my own computer science undergraduates there was, please can you make sure that we have the right ethics education? And this is not, unfortunately, there's no such thing as ethics education which teaches you what the right or wrong thing to do is, because many of these actual situations are much more nuanced than that. but you can educate on how to sort of dispassionately reason about these kinds of issues. I'll give you one example. In fact, we've been very careful to put in full review processes so that every big AI solution that we're coming up with goes through the review process to make sure that we've thought through, even if it looks harmless, all of the potential issues. One example, it would be really good to be able to use drone footage of a construction site to give warnings if some of the people working on the site are not wearing helmets. Turns out that is a large and important issue in the world of construction, is it's quite easy to save a lot of lives relatively inexpensively by enforcing helmet wearing. So seems like a no-brainer. The answer is no, it's not a no-brainer, because you're then starting to ask a question about a particularly, I would say, sensible and reasonable example of monitoring a workforce to make sure they're following the rules. And I think many of us might consider it to be nightmarish to have AIs not just doing things like that for safety, but for other aspects. And so you do then have to take as many existing ethical principles to work through what you're going to do in these situations where there's a technology which may be useful, but could be misapplied, and go through your toolbook of how to deal with it. So I know it's not a dramatic answer. It's another important thing you're doing when you're figuring out a product plan. It comes before something like figuring out the total addressable market or the competitive landscape, is you have to do this question of whether what you're going to produce is something which does match your organization's or your country's principles ethically.
So we've been encouraging people to get involved, and hopefully some of this has done that. But I'm going to quote you from about 9 months ago, where you said, everyone has to understand AI is very, very stupid.
Thank you, yes.
So here we are encouraging people to work with this very, very stupid tool. I'm curious what you would like to see from your organization and or other organizations that would make you either remove one or two of those varies, or actually sit back and go, ooh, that was actually clever of AI. So I'm curious, just looking forward, and let's say 9 months from now, what would make you remove a vary or two, or what would you actually even go further to say, there's some really clever things going on? What's going to be released and enabled?
So let me begin first with the areas of research. There are a very few people, like maybe I would estimate less than 0.5% of all the people involved in AI research are looking at a problem called analogical reasoning, which is where when we solve problems creatively, we very frequently do say, there's this thing that I did in this other part of my life which worked out. Maybe I can apply it here. That's the kind of thing which, seriously, there is no useful technology that I know of. And I spend a lot of time making sure I'm up with technology for helping us do that sort of thing.
We should talk about our technology.
Okay, very good. Yeah. So, but those kinds of things which cognitive scientists are looking at, and which for many people, including me, seem like old-fashioned AI, the kind of things that people were studying in the late 80s. What's going on at the moment in the industry is some aspects of classification from video or predicting, being able to do multivariate forecasting extremely accurately. Those are so powerful in their own rights, we can do society-changing things with them. But that's, at best, lobster-level intelligence. It's nothing like the mysteries of how humans can actually cognate.
Yeah, no, I love that as an example, and I think you're exactly right, having come from, I did neural nets and genetic algorithms, and then went to expert systems, which I think is part of some of what you're alluding to. And those were just hard and clumsy, and something there is a clever key there that I'm completely with you on that. So we just have a few minutes left, and then we're going to be able to take some questions.
Great.
I wanted to do a little bit of rapid fire. So you have a huge audience here of people that are passionately interested in AI. Some of them are wonderful technologists, and some of them are still trying to figure out what their company strategy is. Tell them 1 to 3 things that you say are the #1 things to get started. Rapid fire.
Okay. You've got to know probability theory properly. You cannot fake it with sort of messing around with numbers in weird ways. You have to know what a marginal distribution is and what it means to have confidence in your model. Another one, it's not whether you can predict accurately that counts. It's what decisions are going to be made up the line from this model. Seriously, and by the way, I apologize to many people in this audience who know this perfectly well. So this is not addressed to you because you already know this. It's the loss function that you're using for training. Usually it's not even possible for it to be the same loss function that you're actually using for the decisions. And you have to design that in. Perfect example, something dear to my heart is advertising optimization, showing adverts on web pages using machine learning. You're trying to maximize how useful they are to the user, because if you show useless stuff, the users will never come back to your search engine. And that's very different from accurately predicting what's likely to be clicked on.
So I'm going to ask for 2 things on ethics, because getting started is important, getting people going, and ethics have to be considered, as you said. What would you say are the top 2 high-level things that you would say to people?
There are books on how to have ethical debates, which help you avoid a situation where you're having that debate by polarized people in your organization shouting at each other. So absolutely go for that. Second thing is, it is an absolute industry trend that third-party customers that are coming to Google Cloud for serious AI solutions, one of the first things they ask for is help on making sure they're following ethical principles. So it's good business to be in this area.
That's great. Can we open it up to some questions? Is there anything that you guys want to ask the head of Google's AI, which is Cloud AI, which is the biggest in the world, one of the biggest in the world? We covered all the questions. Nothing is left. Oh, I think we have one. Thank
Very
you.
good.
It's always hardest to be first. Thank you. Oh, we've got 2. We'll come back, I promise.
What would you say the most important new cutting edge work is in AI?
It's been around for a lot, but it's just emerging as commercially important, is active learning. The ability to, for a machine learning system to decide what additional data it needs. In fact, that is some of the technology behind our AutoML project. AutoML, in theory, tries in the order of 10 to the 30 different possible models, but of course it can't actually afford to do that, so it uses machine learning within itself to do this. If you know how to use active learning properly, I think it can improve maybe 30 or 40% of realistic AI deployments.
We do one more? No, they're not going to let me do one more. I'm sorry. All right. Thank you so much, Andrew.
Thank you.
I really appreciate it.
I really enjoyed it.
I learned a
Thanks,
lot.
everyone.
I hope you did too.